Okay, let's start today's class. Yeah, actually, for today's class, there is no more like a theory part for today's lab. Yeah, just like very similar with lab 4 and fab, but use different like sensors like that, like different components. Like we know like for the lab 4, do you remember? Let's recall lab 4 and lab fab. What's lab 4?
Four was using like the voltmeter.
Yeah, voltmeter. Like you just use the potential meter, like adjust the potential meter, adjust the resistor, and try to use pico to read the voltage. Do you remember that? Yeah, and which means you have two resistor, right? R1, R2. Do you remember? And the R2 is just like a potential meter, and you can adjust the resistor for R2. Am I right? And what's lab fab? What's lab fab about? Do you remember? Lab fab.
Oh, yeah.
Yeah. Yeah. Like you use capacitor to replace R2. Do you remember like that circuit? And then try to charge the capacitor and discharge a capacitor and try to measurement the discharge voltage, like using pico. Am I right? Actually, for the lab 7, it's very we just use the same like circuit. Yeah, and we call actually this circuit, this kind of circuit, we have a name for that, the voltage divider. Have you ever heard this before in electronics? I think, yeah, which means you have a voltage, but you want to divide this voltage. For example, you have 3.3, but you don't 3.3. Maybe you need 2, maybe you need 1. Am I right? You don't want 3.3, so you just prepare 2 different resistors, and then get what like the specific voltage you want. That makes sense to you. And this is the equation for this for this point voltage. Yeah. Any questions for the voltage divider? I think this is a very fundamental thing for the electronics. Am I right? And maybe high school also learned this. Yeah. And this points like voltage is just V in the like the total voltage. And this is R2 divided R2 plus R3. And this is just like the divide this voltage, the total voltage, and get what specific you want. Am I right? And then like for the lab 4, we just use potential meter. Yeah, with as R2. Am I right? And for the lab 5, we just use capacitor like replace R2. Am I right? Yeah, if you remember that. And actually, yeah, and we all for the lab 4 and lab 5, we use onboard ADC. Like we use pico to read these points, and the read number. Do you remember the read number is what? When you use pico, what's the read number? What you can get directly from the pico, like input output like that.
0, 1, high, low.
Yeah. Just a binary number. Am I right? Yeah. You just read the binary number, and then you try to like transfer it, convert it to the decimal, and using this equation to calculate the voltage you can read. That makes sense to you? Yeah, this is what we do in lab 5 and lab 4 and lab 5. Am I right? Yeah, actually we use this the same circuit and the same theory. And we talk about this in last class. Actually, you can see in our code, we just use like 16-bit. But in the reality, the hardware ADC resolution is not 16-bit, it is 12-bit. Yeah, it's just like for the convenience and like no addition for the convenience. And the micro like Python scales 12-bit to the 16-bit, like left shift 4-bit. And just for convenient to calculation to like when you do the computation, yeah. And when you do some labs, you will find the 16-bit will be convenient for you. Yeah, but the accuracy is just like a 12-bit. Yeah, just remember that. Yeah, for the pico, onboard pico. Yeah, we talked about this in last class. Yeah, I just want to clarify and thank you for Xander to point this out. Okay, and for today's lab, we will like introduce two new like resistant like atoms. One is photoresistor. I think you use this before, am I right? At least in microelectronics you use it. I don't know if you use this in maybe robot if you want your robot to detect light. Does anyone does anyone don't know this before?
I haven't seen it.
You haven't seen this before? Have you heard this before?
I've heard of it, yeah.
Oh,
I
okay.
haven't seen it.
Yeah, actually the photoresistor is just like a component. Is sensitive. It can sense visible light. Yeah, like approximately 400 to 700 nanometer. Do you know what is those 407 nanometer? Do you know what's that?
Like red to like purple. Whatever it was.
Yeah. This is just example like the visible light. But this 400 to 700 nanometer, it is a wavelength. Yeah, if you learn like the college physics, you learn some light, and this light will have a wavelength. And usually the specific wavelength you can see in your eye. That makes sense to you? Yeah. Do you remember in the college physics? Yeah, actually, this photoresistor can sense like a visible light approximately 400 to 700 nanometer. And for this atom, the resistance changes depends on light and intensity. Yeah, we will talk about more details for this photoresistor later. Yeah, but you just remember like the resistance for this atom will change depends on light and intensity. If you have more light, if this photoresistor sense more light, and it will have lower resistance. If it sense less light, it will have higher resistance. What does that mean? Let me ask you a question. If you cover this photoresistor, what will be the resistor become? What will be
Would
the
it be
resistor?
zero?
Huh?
Would it be zero?
If you cover it, what does that mean? It will sense. What does that mean? It will have more light or less light?
Less light.
Yeah, less light. What does that mean? Yeah, it will higher resistance. Am I right? So yeah, and you can see for this like a circuit, we just use photoresistor to replace R2, which means if you cover the photoresistor, or if you give it a light or some like your phone, the highlight, and it will change the resistance. That makes sense to you? Yeah. So for today's lab, you will try to observe how this photoresistor sense the light from the environment, from your from your action, and then how this circuit voltage will change. Yeah. Any questions so far? For the photoresistor? Yeah, we will talk about more later. Yeah. And then this is the lab activity 1. Yeah. And activity 2, we will like use the emitter. Yeah, this is like you can see, this emitter will have a head. This one. Yeah, actually this one will sensitive to like temperature. Yeah, and the resistor value and there is this cable, this line is just like try to help you to connect to the your circuit. Do you know like usually we just put this head to maybe your hot water or some like environment, but this cable can is a little long. Maybe yeah, you can observe in today's lab, and the resistor value will change. Depends on the temperature, which means if this head detect different temperature, the resistance for this part will change. Yeah, this is we call it thermistor, which it is sensitive to the temperature. Am I right? So today we will talk about two different, what's the name for today's lab? Variable resistors. Yeah, those two are two different variable resistors. And one is sensitive to light and the other is sensitive to temperature. Yeah, and you will find. Okay. And also you will connect this thermistor to this circuit and try to change the temperature, and then the thermistor will change the resistor, and then you will use pico W to detect to read the voltage. That makes sense to you? Actually, it's a very similar process with lab 4 and lab 5. And then for the thermistor, actually there are some equations. Actually, this is the equation for like how the resistor will change for the thermistor. And this rule here, there is a rule. Rule is just we call it electrical resistivity of the wire. Actually, this one will change by with the temperature, and L is the length of the cable, and the A is just the like a cross temperature for a given resistance of our thermistor. Actually, the L and the A actually it's easy to define, but the rule here, it will change. It will be very sensitive for the like temperature. So it is very difficult to detect or to like to measure. So we usually don't use this equation. We use this equation. Yeah, this equation we call it Steinhardt, like Steinhardt equation. Yeah, and you can see for this equation, the T is just the temperature you can detect. Am I right? And the R is just a resistor. So for this equation, what's the point for you? If you want to like define the relationship between the temperature and the resistor, what you will do?
It's just use that equation. So if you want a certain resistance, you can.
Let me, I think you got the point. Let me ask you, in our lab, the temperature will change, am I right? Yeah, and after when the temperature changes, the resistor will change, am I right? So for this equation, actually the C1, C2, C3 is a constant for the specific thermistor. Yeah, so the point is you need to find C1, C2, C3 for your thermistor. And if you find the C1, C2, C3, which means if you know the temperature and you know the resistor, right? That makes sense to you? Yeah, this is what the point for the what you will do in the lab in the activity 2. Any questions so far? Okay, yeah, the theory for the lab today's lab is not that difficult, but you need to very careful for what you will do. Yeah, let's go through the lab 6. Yeah, and the lab 6 today you will like understand how a voltage divider works. Actually, you can see lab 5 and lab 4 and lab 5 also we use voltage divider, but we didn't talk about it more. We don't focus on the voltage divider. We just focus on the read, PW read, because that is what we want to focus. And for today's lab, we want to focus on how a voltage divider works, and then use Pico W or Pico's ADC to read the voltage. Yeah, this is what lab 4 and lab 5 do. Am I right? Yeah, we just review it, and we will measure the light intensity, like photoresistor, and the temperature, thermistor. Yeah, and we will find how to convert voltage and then relate to the resistance, and then relate to the physical quantity. Yeah, because you can see if we change the light, then we change the resistor, and then we change the voltage. Yeah, that makes sense to you. And for the thermistor, we change the temperature, and then the resistor will be changed, and then the voltage will be changed. That makes sense to you. Yeah. So this is today we will like do. And also the voltage divider review. Yeah, we just talk about that. Yeah, we just try to replace R2 with photoresistor or thermistor. And you can see, like the R2 increases, the voltage, the output voltage will increases. The R2 decreases, the voltage output will decreases. Yeah, you need to observe it. Yeah, that makes sense to you. Yeah, from this equation, you can see. Yeah, from that makes sense to you. Yeah, any questions so far? Okay, and then why this is powerful? Yeah, actually, today we will just talk about two different sensors, but there are so many different, so many other sensors in the real world. For example, you detect the humidity, detect the pressure, detect the maybe the different thing, but you will use different sensors. Actually, the main sensors are just variable resistors. Yeah, for today's lab, the like photoresistor is just a light, and the thermistor is temperature. We cannot measure resistance directly. You can try use the multimeter to detect the resistor directly. You will see. Actually, you cannot get the resistor directly. So you need to use some method. Yeah, you use the pico W to read the voltage, and then through the voltage and through the equations we can use to get the resistor. That makes sense to you? Yeah. And then, yeah, but we can measure voltage using pico, am I right? Pico W. And using, then we will use this equation and this equation to calculate the resistor. That makes sense to you? Yeah, okay. Any questions so far? Any question? No? Okay. Yeah. And then for the activity one, we know that it is light measurement. Actually, this one we call it ADS sensor, and the ADS is a cadmium sulfide sensor, and it is cadmium sulfide. It is just some chemical element, and if the light hits this material, and it will like generate some like negative charge and positive charge, and it will make the resistance change for this atom. Yeah, and then actually this atom is just respond to 400 to 700 nanometer light is just visible light, and as light increase, and the resistor will like decrease like that. Yeah, and here there is a raise time and the fall time, and we will talk about the maybe the raise time is just like when the raise time and the fall time is when it sends the light, or when it when you cover it, the resistance will change, the resistor will change, but it will not change directly. Like if you give it a light or cover it, the resistance will not like drop to zero directly, like in maybe very short time. It will go to like a greater or smaller slowly. Yeah, it needs a time to stable the resistor. That makes sense to you? Yeah, this is just that what the meaning for that. Yeah, what should happen? Yeah, if light increases, the photoresistor resistance will decrease and the voltage will decrease. And we just talked about that, am I right? And if covered by hand, which means light like decreases and the resistance will increases and the voltage will increases. Yeah, any question? I think this will be. And yeah, sorry. I think this one is the next activity. This is activity one. Actually, activity one is not like that difficult. And for the activity two, okay. The activity two is temperature measurement. And we will use the thermistor, like temperature dependent resistor. The relationship actually it is not linear. Yeah, and for today's lab, you will find what's the relationship between the temperature and the like a resistor. Actually, I have already given you the equation, but you will find after you draw the plot the figure, you will find the relationship, and the resistance decreases as temperature increases. Yeah, and the relationship between the temperature and the resistor will be this equation. Here, just pay attention. I will give you the temperature measurement, but it will give you some now this unit. Here the T, the temperature here it is Kelvin temperature. Have you ever heard this before? Kelvin temperature? Yeah. You need to convert the degree temperature to the Kelvin temperature when you do the calculation. Any question? Okay, and the R is just like ohms. And the C1, C2, C3 are like a calibration constants. It doesn't have the unit, but it's just a constant. And each semester has different constants. Yeah, so what you need to do is just find your C1, C2, C3 for the semester. Yeah, and then for the activity 2, there is a calibration process. Yeah, actually, for the calibration process, we just based on these equations, and we will do the 3 different measurements: the ice water, the room temperature, and the hot water. Hot water, which means 100 degree. Yeah. But you need to transfer it to convert it to the Kelvin temperature. I think yeah. For each, you measure the voltage, you calculate the resistance, and record the temperature. How can you calculate the resistance? Yeah, because you can use like a temperature measurement equipment to get the temperature. You can read the voltage. How can you calculate the resistance? Do you know? Just use this equation. Am I right? And but this equation is mainly for the C1, C2, C3. You need to use this equation. Am I right? Here, the R1 is fixed. Yeah, you just fix this R1. Here, you know the V in. What is V in for Resistors lab? What is V in?
3.3.
3.3. You know the R1, am I right? What is V out? What is V out? Actually, the V out is just the measure voltage. You can measure it. You can read it from the pico. That makes sense to you? Am I right? Yeah, so which means you can use this equation. You know the V in 3.3. You know the R1, am I right? You know the V out. You can calculate the R2. That makes sense to you? Any questions? And then you can see, you know the R2, am I right? And you know R2 is same with here R, am I right? You know the R, which means you know the R, you know the T. Then you want to calculate C1, C2, C1, C2, C3. You have 3 different unknowns, which means you need 3 different equations. Am I right? That's the reason why here you need 3 different measurements. Any questions? Okay. Then you can resolve like 3 equations to find C1, C2, C3. Any questions so far? Okay, yeah. And okay, let's try to talk about the temperature vs time data logging. Yeah, actually, I will now give you the code for today's lab. Actually, the code is very similar with lab 4 and lab 5. Yeah, for this activity 2, you modify previous capacitor discharge logger, and instead of faster sampling, use slower sampling. Yeah, because you can see the time when you do the lab, you will find that when you hit the water, it is very slow. And now like the discharging or the charging capacitor is very fast. Yeah, but for the heat water, it is very slow. You can you need to use slower sampling. 1 second or 2 seconds. You can try to adjust that. And the measurement like a temperature vs time for the 30 centigrade rise. Yeah. And for today's lab, I want you to calculate the heating power. Yeah. Actually, this is the physics review. This equation, have you ever? I think you know this, right? This is heat energy. What is M here? Oh, M, I just give you. It's just a mass of water. And C is just a constant. The data is just delta T is just like a temperature change. And then you can use like a mass of water and the constant and the temperature change, you can get the heat energy. Then you use the heat energy to calculate the power, heating power. The T here is just a heating time. You just record your heating time. And for this Q, that makes sense to you? Any questions so far? Actually, this is just like physics thing to calculate the heating power. Any question? Okay, and what you will demonstrate today, like light detection works, temperature reading works, calibration complete, power calculation complete. And this is what you will like demonstrate. And common mistakes, wrong pin, and wrong voltage conversion, and sampling too fast, forgetting to refresh files. Yeah, you need to pay attention to now make those mistakes. And also, I didn't put it here. For today's lab, we need a grouping. We need a group working. So 2 people, 1 group, and you need to find a partner. And I will like see you must finish the lab with your partner. And when I check off, you need to like finish the check off with your partner. Yeah. Why we need a partner? Because for the activity 1, I think that's fine. You can do it by yourself, but if you have a partner, you can see you two can work together to make different lights. That will be easier for you. And especially for the activity 2, you need to add water, measurement the water. Yeah, 2 people will be convenient to finish the lab. If you just one, and it is not easy for you to finish the whole lab. Yeah. Any questions so far? Yeah, you need to find your own partner. I will now give you a specific partner. Is that okay? Do you want me to give you a specific partner? Huh? Do you? No? Okay, I think you can find your own partner, because this is yeah, this is not that difficult. Okay. This is just today's lab. Any question? Yeah, and you can find the photoresistor and the like the semester there, and all the equipment I will give you. I will put it here, and also, we will next we will talk about the final project. Yeah, have you ever checked the final project? No. Yeah, let me talk about again. In the final project, each group will design and build a microcontroller-based assistive device that helps a user with cognitive difficulty complete a daily life task safely and reliably. Yeah, and then we will have 4 groups, and different groups will focus on different tasks. And yeah, and group A will like hearing. Here will focus on hearing impairment. Like there are different. The group B will vision impairment. Group C will force operation. D repeated medication. Yeah, and different groups will have different difficulties. And there are some challenges for different groups, and usually there are some common mistakes you will have, and there need different groups will need different engineering skills, and you can see group AB may look simple, but require careful design thinking. You need to think. You need to design like different situation. Yeah, because you can see for example. Actually, you just do your research, your own research. I will now talk more for you. You need to like brainstorm. Yeah, your group. Yeah, for example, hearing impairment, which means the people will not hear, or will not have a good hearing. Am I right? So, which means if you want to give a user a hint, you need to use vision hint, am I right? Some flash. But you can see there are different situations. For example, time to eat, time to drink, time to wash your dish, time to take medicine. Different situation. You will give different hint, am I right? What you will do? What you will do? Actually, there is a very simple way. You just use different color, am I right? Different color to give different hint, am I right? That makes sense to you? Yeah, don't think it too complicated. Yeah, it's just like use some easy but very efficient way to give user a very obvious hint like that. Yeah, if you have any question, if you have doubts, you can talk with me. Am I right? Yeah. Is that okay? Yeah, don't think it too complicated. Actually, like in the real world, some questions may like looks very difficult, very complicated, but you can use very simple, very easy, very efficient way to resolve it. Yeah, don't think too much. Yeah. So yeah, you can think about it. It will be very interesting. Yeah, and this is our grouping. I have already put it on Blackboard. Did you see it? Did you check that? Yeah. So any questions so far for the grouping? Okay, that's great. We have time for now. And you're like you need to give your which group, like group A, B, C, D, which group you want to choose in today's class. Is that okay? Yeah, find your group members and talk about that and give your which group you want to choose and then
All right.
There again is which one is it? So. Angela. I was. Well, the project being like, the project being like, the one where they jump the random, see which one you yeah. Yeah. Just really, so, yeah, frequent. Oh, I know. Especially, you're being good.